Hello, everyone. Thank you so much for joining our webinar this evening. I'm so excited that you are on, you're ready to learn, and have taken some time out with us tonight for our first webinar week of the new year. So happy new year. For those of you who I have not met yet, I'm Morgan Boykin, and I'm our community and volunteer coordinator here with SC Codes. I am so excited to have a chance to sit and learn with you all tonight, as well as help facilitate the conversations when we get to that Q&A portion, and also introduce you to one of our fabulous volunteers, Mr. Will Tome. So I am not going to spend a lot of time rambling. I want to get you right into the information. Will is on our call now and ready to share. So to introduce him to you, Will is a solutions architect at Red Hat. He spent much of his career focused on infrastructure, cloud, and automation solutions. He's passionate about sharing his knowledge, which is why he's here with you tonight, mentoring and collaborating with others. In addition to his enthusiasm for technology, Will also holds his private pilot certificate. So those of you who have seen our social media posts this week and are wondering who that cool guy is flying the plane, you're going to meet him tonight and have a chance to learn from him. And so, of course, with that, he enjoys learning more about seeing the world from the sky. So I'm excited for him to share his expertise with you tonight. If you have questions, feel free to throw them into the live chat. We'll have a chance at the end to read those questions off. If you submitted questions beforehand, I have those, and I'm going to be reading those to Will as well. So definitely take notes. Ask questions, get involved. We want it to be as interactive as possible. And with that, I will hand it over to Will. Thank you so much for being here, Will, and thank you so much to everyone in SC Codes land for joining us tonight.
Thanks, Morgan. I'm really excited to be here to do this webinar with all of y'all, and so thank you for joining. Like Morgan said, I work for Red Hat. If you haven't heard of us, we are the open source enterprise company. We provide all kinds of different enterprise ready solutions based off of all open source technology. So what I'm going to be talking about today is how to get started using the source control system called Git. And while this isn't necessarily something that is going to be directly teaching you how to code in a different language or how to use new styles and techniques in your code, this is more of a skill that's going to be integral to your career as a developer. So with that, let's go ahead and get started. So the first thing that I want to talk about is, what is source control? So source control is a set of practices for tracking and managing changes that we make to our source code. Now, that could be as simple as really taking a file and making a change to it and then adding version 1 to the end of the file or version 2 to the end of the file. Anything like that is a way of versioning and tracking changes to your code. But especially as we start to work in larger teams and we start to want to collaborate with others on our teams and on our software projects, we need a better way than just passing around files with different version numbers. So to accomplish that, we often use a source control management system. And we're going to talk about one very popular one today, but you're going to run into probably many others throughout your professional career. And what these source control management systems do is they help you facilitate this collaboration and this tracking and history of your code. If you ever helped someone out or even maybe been looking at your own code and wondering, why this worked yesterday, why didn't it work today? What changed? Who changed what? That's what the source control management system helps you keep track of and helps you control with your code. So as you can see on the picture on the right here, we might have Anne who wants to make a change to the code. So she creates what's called a branch. And as she's developing, we have Robert who makes an important change that needs to be included with Anne's code. And so that source control management system allows Robert allows Anne to pull Robert's change in while she is developing. And then once she's completed her new feature, then she's able to merge that back in. So it's this idea of taking our code and creating these different copies of it, and then bringing that all back together to be our final main branch of code. So what is Git? This might be something that is that you've run across so far in your development career. This Git is the most popular source control management system that is out there today. You might also have heard of Subversion, or commonly called SVN for short. That's another older system that is still in use at a lot of companies, and you may still run across, but we're going to focus on Git today because that's what you're most likely going to see, and what employers are going to look for skills when you go on an interview or when you accept a job. So what makes Git so popular and so great? Well, part of it is the distributed design of the Git technology. It allows you to take independent copies of your code or of your team's code and pull that copy down to a development server that you're working on, or pull that down to your laptop. You can make changes without being connected to the internet, without having any sort of connection to a centralized server. You can make the changes that you need, and then you can sync these changes back with your remote server. And Git is really, really good at taking your code and weaving it together with your other team members and other changes that have been made to resolve conflicts. If I've changed one line of code, Morgan's changed another line, Git will try to figure out how those lines fit together when we bring it all back together. If not, it gives me a way to select whose code do I want. Do I want Morgan's code? Do I want my own code? Or maybe I need to manually put those two together. So it helps facilitate resolving those conflicts that we might have in our code, and then merging them all back into one main copy of our code. This also allows us to track differences, understand when a potential bug might have been introduced into the code base, understand when a change might have introduced a security vulnerability. So when we're going back to do any sort of post-mortem analysis on our code, we're able to track those differences, see exactly what was changed when, and understand better how our application is behaving in production. It's also secured using SSH. So it makes it very lightweight, very quick, very secure, and easy to use. The same SSH keys we would use to connect from one server to the other, we're also using to connect from our laptop to our Git server to transfer these changes back and forth. And as part of this distributed design, Git keeps different incremental changes, keeps track of different incremental changes rather than keeping track of an entire code base. So when you're looking at making changes to large code bases, such as maybe the Linux kernel or Kubernetes, you don't want to have an entire copy of that code base multiple times on your machine. It takes up a lot of space. It also takes a lot of work over the network to transfer that giant code base back and forth. So you don't need to necessarily interact with this as the developer, but just know that Git is keeping tiny little differences of your code together in its little .git directory, and then that's how it is communicating with your peers and with other remote servers to sort out what changes have been made to the code. The way I like to think of it, if you're new to Git, is think of it as like a giant offline Google Docs for managing source code. So let's talk about GitHub. If you've heard of Git, you've probably heard of GitHub. Well, GitHub it's essentially a social network for coding. It's an online service that allows us to host our code bases. So I'm able to write code and push that up to a Git server. And I could run my own Git server, but I could also just use GitHub. Then I don't have to run my own server. Then I have a community, just like our other social networks, a community of other developers all working on the same platform that can review my code, that can make changes to my code. I have other systems that might do security scans on my code. I can hook this into other development tools to do automated testing of my code. There's a lot we can do by integrating with these other systems, and GitHub is kind of the core, the most popular service used in order to facilitate that. It makes it very easy to collaborate with not only your peers or maybe within your company, but also with other open source communities. Many of them are hosted on GitHub, and you can jump right over there and make changes to maybe a Ruby gem that you're using or a node module that you need for your project. And so it brings all of that to one place. Now, this is not only something that's used for open source communities and that are used by individuals to host their own software projects. GitHub also offers services to enterprises. So you may find that your employer uses GitHub as well, but rather than keeping all of their code out and visible and available to the public, they use something called GitHub Enterprise or private repositories so that they can have private tracking of their own code, and then you can be added to that organization, or someone can add you to one of their private repositories so that you can collaborate on that. So if we look at some of these stats here on the screen from last year, GitHub had 60 million new repositories created over 2020. And 56 million developers were active on GitHub working across these repositories, and they generated 1.9 billion contributions to different software projects. And finally, like I mentioned, 72% of the Fortune 50 companies use GitHub Enterprise. So it's very likely that this is something that you'll see not only in your personal development career, but also in your professional development career. Other alternatives that you might run into, just so that you're aware of them, are things like GitLab, which is an open source alternative to GitHub. Bitbucket, which is made by a company called Atlassian that makes a suite of developer tools for tracking your sprints and keeping track of your code and issues to keep your project on track. Perforce is another one that I see a lot of times as well. So while you might see these different systems other than GitHub, they're all using the same Git technology underneath. Even Microsoft, in what they do on Azure with their Visual Studio Code servers, has the ability to use the Git technology. So despite what your service might be, you're likely still going to run into Git one way or another. So let's talk a little bit about how Git works. So we start from a remote repo, and the remote repo is something that lives on our Git server. So this might be on GitHub or on our GitHub Enterprise, on our own internally hosted Git server at our company. And that remote repository is the place that all the developers ultimately sync and push their code back to. So what we're going to do, the first thing we want to do is we want to clone, or we want to pull a copy from that remote repo. And that will create a local copy on our laptop or on our development server. And again, we don't have to be actively connected to the server in order to do this. So when we do that pull, we need to be connected to the network. Then we can be disconnected. We might need to go travel to a different place. We might need to go and switch to a different network to access other parts of our infrastructure. Maybe your Git server goes down. We hope that doesn't happen, but you can still continue working in your local directory. From there, you can either change existing files that were pulled down from the remote repo, or you can add new files. And when you add new files, there's one little extra step you have to do is you have to tell Git that you've created a file and that you want it to track that file. And when you tell Git about that file, it will then start to watch it and see when you make changes to it. After we have all the files that we've added to our project, or we've changed existing files and we've implemented a new set of functionality, we want to commit that. And with our commits, think about it just as we would build functions in our code as well. We wouldn't build one giant function that takes in a whole bunch of arguments and then does 8 different things. Our commit, we want to think about is the same way. We want to commit code that is, we don't want it to be too small. We don't want to commit every single time we change one individual file. But once we complete one small, easy to review, easy to understand piece of functionality, we want to commit that. And what that commit does is it puts a mark in the sand, if you will. It says, okay, I've made these changes and I'm going to kind of stamp right here and say all of these changes go together. And we can make multiple commits against our working directory as we develop and as we add different functionality. And these commits are important because there are other features that we're not going to talk about today, but other features in Git that allow us to pick specific commits that we want, or go back and exclude specific commits as we take our code and we push it back up into the main project. So we might have one commit, we might have several commits that we've made locally. And then once we do that, we take our local repository and we sync it with the remote repository by pushing our changes back up to the remote. And when we do that, that is when Git looks at the code that's in the remote repository and looks at the code that we have changed and tries to merge and stitch all that together. Because while you're making your commits, while you're doing your own local development, other people might be making changes to the remote repository. In that case, Git's going to try to stitch everything together. It's also recommended that you do a pull from that remote repository to make sure you have all the latest changes, and you can resolve anything that might have been changed since the last time you downloaded a copy before you push. So then we'll take our changes, push them back up to the server, and then we start the whole process again. Other people will pull down our changes down to their local working directory, make changes to either our code or other code, and then push it back together. And this is the cycle that we follow to continue to all collaborate and all contribute back to a main code base. So there are a set of commands that Git has that allow us to integrate, or that allow us to run through this workflow that we just talked about. And I'm going to go through some of the most basic commands here, some of the ones that you're going to want to use to get started. At the end, I'm going to share a cheat sheet that has a whole bunch of useful Git commands, depending on what you're trying to do within your project. So the first thing you're going to do after you have a remote repository, either you've created one on GitHub or someone has sent you a link to one so that you can work on it, is you're going to take the URL and you're going to run in your terminal Git Clone and then paste that URL in, and that's going to do that initial download of the remote repository to your system. When it does that, it's going to create a directory. It's going to create a folder on your laptop. And so we want to change into that directory. And I like to have a folder that has all of my different Git repositories in them. You can then take those Git repository folders and I can move my working directories around if I need to copy it over here or copy it over there. Everything's self-contained inside of that directory. So we just pulled down a brand new repository, and so we're going to create a new file called readme.md. This is a Markdown style file, and most of our Git servers are going to interpret this Markdown file for us, and then it's going to render it in the Git server. It's a great way to document our code but still keep our documentation as code that we can control using our source control system. So now that I've created this new file, I'm going to run git add readme.md. I created a new file, so I need to tell Git about it. Otherwise, it's not going to keep track. So I add that file, and then I'm going to run git commit, and the -a here means all. So that just says commit all the files that have changes. And when we do this, typically your computer will open up your editor. Maybe if it's set to VI, for example, it will open up a Vim window and you can type in a message. And we're going to talk about these messages a little bit more, but the message allows you to add a little note around what this commit is, what's part of it, what did you change, what did you do. You want to keep those commit messages short, but also have them descriptive enough that somebody else can read and understand what they're about to look at in the code. It gives them some context, especially when reviewing others' code. Finally, you're going to want to push this back up to your Git server. And so we're going to run the git push command. And now we have a couple other things here that I'd like to explain. So the -u says track an upstream branch. So the name of what you have locally is the same as what you have on your remote server. Origin is the default location of your remote server. And so when you did that Git clone, it automatically created a remote location called Origin. Being at Red Hat, I work on a lot of different open source projects, and to make little contributions to them here and there. So often I have a copy of the project of my own that I can play with, but then I also have I also point my repository to an upstream, what we call an upstream repo as well. So I might have sometimes I might run git push upstream main instead of git push origin main. Origin would be my own, upstream would be someone else's. You might run into the same thing in your environments, that there are multiple different remote servers that you have to sync your code with. But if it's just you, if you're just getting started, Origin is just the name of the location of your remote server. And then main is the branch. So we're going to talk about how you can have different branches. Like we looked at the example at the very beginning when Anne created her own branch for her new feature. You might be committing back to git push origin my feature, or git push origin issue 1119, or an issue number, a ticket number that is being used to track your project. So those are the basic commands that you'll need to know. Again, I'm going to share that cheat sheet that has a whole bunch of them. For you. There's actually one that I didn't put on the slide that's probably the most important of them all, which is the git status command. I run this command all the time because it tells me what Git is thinking. And when I run the git status, it'll tell me, hey, this file isn't being tracked by Git. Do you want to add it? Hey, these files have changed. Hey, you've added these files to this commit, or you've staged these files for this commit, but these other files you haven't staged. So I like running the git status command to understand how Git sees my code so that I know what the next command I need to run is. All right, so now we're going to switch over and do a live demo. We're not here just to do slideware tonight, so let me just switch over the sharing of my screen, and we will be good to go. All right, so now I am over here. I have my editor up on the left side of my screen. I have my, I'm logged into GitHub on the right side. And the first thing we're going to do is to create a new repository. So I'll jump in here to the repository section, and I'm going to create a new repository here. It's going to be under my name. As you join different teams and work with different organizations, you can house those repositories under your own profile or one for your team. And then I'm going to create a repository over here for anyone who's gone through the front-end basics class and has done the Dragon calculator exercise. I'm going to create one for that. So I'm going to call it Dragon calculator. All right, so I'm going to make this repository public. I like to share my code as much as possible. There's nothing in here that is private or that I need to keep out of the public view. So I'll leave that public. I'm going to go ahead and initialize this with a README file and a Git Ignore, and then I'm going to not include a license today. Maybe we can do another webinar on open source licenses down the road. So I'm just going to start with those two. Oh, I need to just choose my let's see. What do we have here? We have our Git Ignore. Why isn't it letting me create? Oh, I don't have a template for HTML, so we'll just leave our Git Ignore out for today. But when I pull that down, I'm going to talk about what that file does. Okay, so I'm going to go ahead and create my repository here. And now I have an empty repository. It has already started me with a README file and created an initial commit. So I am ready to go. Now, in order to add my code to this, I need to clone my repository. So I'm going to click up here in the code button at the top right corner, and I'm going to copy this URL that it provides for me. Now I'm going to jump over into my editor. For anyone who doesn't recognize it, I'm using Visual Studio Code. This is one of my favorite editors to work with, and the real reason why is because, one, it's going to work across Windows, Mac, Linux, all pretty consistently. The next thing here is I can also work all in one environment. I have my terminal here at the bottom. I'll see my files over here on the left side. And we're also going to look at some of the features that Visual Studio Code offers for enhancing our experience with Git. So I'll run my Git clone and paste that URL. It's going to make a copy from the remote server down to my local machine, and then I'll change into that new directory that I have called Dragon Calculator. Now, we can see here that when I changed into that, you notice this little main popped up in my terminal. That's because I have my shell is set up to add the branch name to my prompt, so I know where I am in my code. This is a common add-on to your shell environment, so that you can easily, quickly see from your prompt where you are in the repository. Now, what this did, I'll run just a list command here real quick, so we can see what is in this repository. Inside of it is my README file, which we saw over here in the web interface, but also it created a .git directory. And now this .git directory is where all of the information about the files and the changes, all that stuff is stored, all the configuration of where my remote servers are, all that kind of stuff. So we're going to leave that alone, but just know that it's there. And if you delete that by chance, you're going to lose the history on your local copy, and you're going to have to re-download from the remote server. So if you're looking in your directories and you see that, don't delete it, or take a look inside of it. you can understand what kind of what Git repository, what server this is connected to. Okay, so now let me open this up in Visual Studio Code. Just going to pull it up into my file browser over here, and again, we see that I have my my README file. Now, I want to add a couple files into here. One of them is going to be my index.html. So I'll create that file, and I'll take my my code that I wrote in front-end basics, and I'll add that to this file. Now that I've added my code here, I'm going to click save, and that is saved. All right, now next I'm going to add my styles.css file and take all of the cool style sheets that I wrote and add those in as well. Save that. And finally, I'm going to take the JavaScript that I learned. And add that in as well. So let me just take that code, add that to the file, and I'm all set. Now, we can see that Visual Studio Code is changing the colors and adding little icons next to my files as I go. That all of that color changing, those little icons, that actually has to do with the fact that I'm working inside of a Git repository. Visual Studio Code understands that, and it's saying, hey, you have a new file. Check this out. It's untracked. That's why there's the U. And I can verify that by coming back to my terminal and running. And running the git status command. And now when I run that git status, this is what I meant by it lets me know what Git is thinking. It's telling me I'm on the main branch. My branch is up to date with origin main. Git doesn't know, right now it doesn't know about any changes that have been made to the server that I don't have locally. It's now telling me that there are untracked files. There are 3 files that Git knows are there, but it's not keeping track of them. If I go make changes to them, Git is not going to know what those changes are. So it even tells me to git add these files. So I'll just run those commands, git add index.html. Now, that's one way to do it. And by the way, if anyone noticed that U changed to an A when I did that, that's one way to do it. The other way to do it, if you don't like typing a whole lot of commands, is I can actually come over here to the source control section of Visual Studio Code and see that now I have 2 untracked files and I have 1 file that's staged for changes. So I can come in here and I can just click add scripts.json, add styles.json, and now all of those are staged for a commit. If I come back and run a git status, we now see that it's not telling me that I have untracked files anymore. Now it's telling me that I have changes that need to be committed. So what am I going to do next? Well, I can run the git commit -a command. When I run that command, it's going to bring me into the editor where I can add a message about my commit. So I'm going to say add initial files for Dragon calculator. And then I can save this. File. Now, I'm not going to save this here because I want to show you one other way in Visual Studio Code that you can do this commit. So I'm just going to quit here And when I do that, all right, I'm back to where I started. Since I didn't actually save that file, my Git commit didn't end up happening. It didn't take. I'm right back where I left off before I tried to add that message. So the other way I can do it in Visual Studio Code is I can just come type my message in here. I can say adding initial set of files. And then I can just click the check mark here to commit my changes. All right, now that I have changes committed, that's awesome. There's one last thing I need to do. If I go over to my repository again here and do a refresh, nothing. There's no new files. Why is that? I need to actually push my changes up to my remote server. So we see right here, it's telling us there's 0 to pull down, 1 to push up. We see it down here as well. We can actually click on that, and that will do the sync and push that one commit back up. And then I will run a git push -u like we saw on the slide. Origin main. And now when I do that, Git's going to talk to the remote server, and it's going to tell me here that I've now gone from, these are actually considered versions, if you will. It's a hash that represents that unique version of the code. And so we've gone from this version now to a new version, and we're doing it on the main branch, still on the main branch. That's awesome. We're going to go up here and refresh on GitHub, and now we see our files are there. We added them 2 minutes ago, and we see our Git commit message here, adding initial set of files. So again, let's look at one other example of how we can use Git. And so I'm going to change my windows here real quick. Looks like my screen is cutting them off. So give me a second to update what I'm sharing, and then we'll go through this again. All right, now that I am back with you, hopefully this will work better this time. Okay, so that's how I would create a new repository and add code to it. Now, what if I'm working on an existing project, someone else's code, or maybe I'm collaborating on a project with a team. So I'm gonna go back here, and let's jump over to a repository I have for a website. Okay, so here I have a project. This is a website that I've built, and it has all the code in here, and including my README. And one thing that's really neat about what GitHub will do for us is, you remember me mentioning that there are extensions to check for doing testing on our code, or check for security vulnerabilities, different things like that. Well, here we see that Git has found a potential security vulnerability in my project. And so one of the libraries that I am using for that I'm using as part of my project has a security issue. So I'm going to look here and see that the Ruby gem Nokogiri has a low severity security alert. And as I read through here, I see that all I need to do is really update the version of that. Well, that shouldn't be that big of a deal. It tells me a little bit about what the vulnerability is, what causes it, different references to this. And so now I want to go and update this. All right, so how do I do that? Well, I'm going to go back to my source code. And in here, now I'm going to switch to a different project. We're done with dragging calculator now. Now we're going to look over here at my website called maxdep.io. And you can see that there are some other things that I'm working on here. Some other changes that I'm working on in my HTML, in my CSS, in my JavaScript. And I can confirm that by running my git status command. And we see that there are changes that have not been staged for commit, and that's okay because I'm still developing locally. I'm still working. I'm still working through that, and so I don't want to commit those yet because then they would go live. But what I do want to do is there's a file in my project that specifies all of my dependencies, and it's my gem file .lock. And so this is saying all of the different versions that I'm using. And when we looked on GitHub, it told us that a version in here needs to be updated. Well, we won't go into the details into the depths of Ruby gems right now, but I'm going to go ahead and make the change real quick and show you how I would commit this back. So in here, I'm just going to run a bundle update real quick. It's going to go ahead and update any versions with whatever the newer version, available is. And when I did that, we see that it generated changes to this gem file .lock. And so inside of here, it's made some changes by running that command. And so I need to commit these back up to my remote server so that everyone else starts to use the same versions of these other libraries. So to do that, I'm going to come in here, and now that we can see this side of the screen, you see all of the different changes that all of the different changed files that I have. So we already said I'm still working on my HTML and my CSS and my JavaScript, so I don't want to commit those right now. So rather than adding all of my files this time, I'm just going to add one. So I'm going to click the plus here on my gem file. Now that file is staged for commit. If I come down here and run my git status command again, we see that it has one file that's ready to be committed, 3 other ones that they aren't quite ready yet. Okay, so now that is staged, I'll come in here and put in my message, update gem versions for security. And I will make that commit. So now if I run my git status again, now let's read this message real quick. I'm on my branch master. The branch is ahead of origin master by 1 commit. So there's one change that I have made locally that has not been pushed back up to my remote server. Remember that remote server, we call it origin. Okay, so it's even telling me use git push to publish my local commits. So let's try that. I'll run a git push. And we have pushed all of this back up to our remote server. So when I go back into GitHub, we see that now my security vulnerability is gone. If I go into the security tab on GitHub, I don't have any more security advisories because I just fixed that. I just updated the version that it told me to. I pushed that back to the remote server, and it's telling me I no longer have those open vulnerabilities. So that's a quick demo on using Git both on a new project and an existing project. So let me switch back over here to the slides. I have one more thing to share with you, and then we'll take some questions. So if you do have some questions, go ahead and stick those into the chat window, and we will get to those soon. All right, so I want to leave you with a couple do's and don'ts with Git. So to start, use a README, document your code, look up a Markdown cheat sheet. Markdown's very, very easy to use, and it's a way of writing your documentation, being able to do lists and include images. It's kind of similar to basic HTML in a way, but it's much easier to write, and it's great for doing your documentations. Also, the Git Ignore file. If you create a file called .git ignore, you can put different files, directories that you don't want Git to track. You want Git to ignore. So one thing that's really, really great to put in your Git Ignore file is if you have any secret information. Let's say you have an SSH key, or maybe you have a file that contains access and secret keys to access something like AWS. Put those in a file and put the name of that file in your Git Ignore. That way you can't accidentally commit secret information back up to Git. If you have things that download, when you compile your code and it produces different artifacts, you might want to put that directory that it downloads those artifacts. You might want to put that directory in your Git Ignore so that those files don't get pushed up. As you saw when we created the repository, depending on the language that you're working in, GitHub will provide you with a sample .gitignore file to get you started. So document your code, ignore things that don't need to go into the upstream repository. It will help you stay organized. Next, break up your commits. You want them, like I said, you don't want it to be so small that every single character or line that you change is a commit, but you also don't want your commits to have so much in them that it becomes hard for other people to read and review what in the world you did. So make a change like, I updated my, I updated the CSS to do this. Okay, that would be a good commit. It's kind of one thing that we did, one thing that we are able to share with others, and they can then review. This is going to be really important as you work with others on your projects as well. Use concise and descriptive commit messages. Now, I'll tell you, I break this one all the time as I'm furiously developing. I'm frustrated, and I just put something in the commit message because I want to push it and see if it passes the test or if it works. So that happens. It happens to all of us. I'd be lying if I told you I didn't do it. But try your best to use concise and descriptive messages in your commit so that other people know what's going on. The other thing, go participate with an open source project. Find something that you can contribute to. Find another someone else in SC codes and work on a project together. Go practice using Git. It's a learning process. You're going to learn new commands. You're going to find something that you did and be like, oh, how do I undo that? Oh, how do I do this? I saw this happen in another project. How do I do that in my own project? So the best thing to do is go get on GitHub, start participating in things, and that's going to be the best way for you to really learn and pick up those skills that you'll need for the real world. Now, let's talk about some of the don'ts. What are some of the things that we don't want to do with Git? One, don't commit sensitive information or large files. Git is not designed to store big files. It's not designed to store binaries. It's designed to store your source code. So keep source code in Git, take your big files and store them in other places. Put them in an object store, put them in an artifact repository, keep that stuff somewhere else. Also, don't store your sensitive information in Git. Even if you have a private, private repository, don't put private stuff in there. People can still go and look at that even if they're on your team. Just like you wouldn't put your credit card number in your Facebook profile, or you wouldn't tweet your social security number. Don't put sensitive information in Git. Keep that somewhere else. Don't commit directly to the main branch. I did do it as part of the demo. It's something that that happens, and that it's very common to do, especially if you're the only one working on your repository. But as you go out into the working world, as you start to collaborate on bigger projects, committing to the main branch is going to be a no-no. Make your commits to a feature branch, some sort of sub branch, and then once everything is together in that branch, then you'll merge that branch back into main. It allows us to do other things like code reviews and automated testing and things of that nature, so that our code stays safe. Also, don't copy other people's projects into yours. And this is not a, it's illegal or it's disingenuous to do. This is more from a code management perspective. You saw me when I did my gem update. I updated a requirements file, essentially specifying what versions of dependencies I needed. I don't need to go and copy every dependency from all over the internet all into my one project. So put the things in your project that you're going to need to reference external dependencies that you have, but don't feel the need to start copying other Git repositories into yours, other libraries and things that you might need into your own project. And finally, don't stop learning. We went over about 4 or 5 Git commands tonight, but there are tons more. People have entire jobs of managing source control systems. Think about how large code bases like an Amazon work. That's not going to be everybody for themselves pushing into the main branch. A mistake there could cost the company millions and millions of dollars. So don't stop learning. If you're very interested in this, there's a whole world out there for your development pipeline, how you manage your code, and so forth. So those are some quick do's and don'ts. And finally, some resources that you can use to learn more. First of all, if you have any questions, feel free to find me in the SC Code Slack. Also, if you want to poke around my GitHub, see any of the things that I'm up to, I'm Will Tome on GitHub. You can find me there as well. What can you do next? Go create an account on GitHub, personalize it a little bit. Put that you work with SC codes. Put a picture on there. Add something. That way it has a little bit of personality to your project. Your GitHub will become a portfolio of the work that you've done. It's one of the best places that employers can go and look and see, what have you actually done? And everything on your GitHub doesn't have to be perfect and super sophisticated and everything else. It can be an open scrapbook of things that you're working on. But one thing that as an employer and, in talking to other employers, it's one thing to interview and ask you questions and have you answer those and draw things on a whiteboard and explain things to me. But it's also good for me to be able to go look and see, what are your side projects? How do you actually write code? How do you manage code? That gives me a much better insight into you as a developer. Atlassian has some great Git tutorials. I think that they have some of the best walkthroughs out there. So if you go to atlassian.com/git/tutorials or just Google Git tutorials, that's a great place to find them. And then the URL is a little bit long for the cheat sheet, but either Google Git cheat sheet or go to this bit.ly/sccodes_Git, and that's going to give you a quick cheat sheet of a whole bunch of commands that you need. So with that, I know we're a little bit over time for tonight, so thank you all for joining and sticking around. We'll go ahead and open it up to some questions. And again, I'm on Slack. If you think of something later on, come find me. If not, I'll stick around and answer questions as long as you keep them coming.
Awesome. Well, thank you so much, Will. Hopefully everyone out there can see and hear me. I know that we got a couple of questions in the chat, so I'm going to go ahead and read those off to you. Let's see. And thank you all for everyone who submitted questions. I'll go with Roy first. Hi, Roy. I saw that you said hello to me as well. Let's see. What can you do to undo a mistake like committing a secret to GitHub?
Okay, so that's a great question, Roy, and it's something that it happens to the best of us. So if it happens to you, don't feel bad about it. We'll just deal with it. Typically, our Git history, the changes that we've made, we don't go back and overwrite those. So if you've made a commit that has something in it that shouldn't be, oops. We're just going to have to deal with it. Same thing as if you send an email that you didn't send. Well, we can't take it back, unfortunately. So a couple good things to help you there to prevent that. One, keep your secrets in a separate file. Use things like environment variables for secret information so that it never actually sits in a file. Or if you do have to put it in a file, put it in a file that is explicitly in your .git ignore, so that you don't do that. It's a good habit to not hard code secrets into your code as is. Now, if one of those does sneak out into the environment, well, we could try to quickly delete our repository so that it doesn't end up on the, nobody finds it or something like that. But really the best thing to do at that point is to go and rotate your secrets. Just like if you lose your credit card, we can go in and maybe pause it while we try to find it. But ultimately, if our credit card is gone, there's nothing else we can do except for cancel that one and get a new one. So that would be my advice: is take the best steps you can to try to avoid doing that. Protect yourself a little bit with environment variables or separate secret files or files that are outside of your repository so they don't accidentally get committed. If they do, go ahead and rotate your keys, rotate your secrets, and then your old secrets aren't useful anymore.
Awesome. Thank you for that. Hopefully that answers your question, Roy. Our next question is there a thorough guide to do a simple one-page website, maybe hosted on GitHub to practice Git commands? And that was from M. Chris.
So look into something called GitHub Pages. That website that I actually showed you is set up for GitHub, what's called GitHub Pages. And when you make commits directly to your Git repository in this, with this kind of specific file structure and this GitHub Pages feature enabled on your repository, it'll automatically host your website. And so I like it a lot because it kind of kills two birds with one stone. I get source control management because I'm pushing all of my code to Git. I get to practice with Git in order to do that. I get website hosting, so now I'm not trying to link together source code into deployment on a specific web server or to a specific web service. GitHub will just host it for me. It's a great way to build a little portfolio for yourself, maybe just a little one-page website, who you are, a simple little resume. The fact that you're doing it on GitHub and you're hosting it with GitHub Pages also shows your skill set in that area as well to potential employers.
Wonderful. Okay, I think, and Will, you did an awesome job answering those questions that came in beforehand, so I know everyone appreciates that as well. Thank you for sharing your information, and I would encourage everyone out there. Well, we did get a request for a part 2, so hopefully we can chat about that soon. Thank you so much for sharing all of this great information. I will stick around if there's any other questions about SC codes, but please join me in just thanking Will for his time tonight, for sharing such great information, and definitely, I think everyone is leaving knowing more than when they came. So that's always a wonderful thing. So thank you again, Will, and thank you for sharing that info. Please reach out to him with any additional questions. And thank you all out there in SC Codes Land for joining us. We hope you have a great rest of the evening. Thanks again, and I will chat with you all very soon. Thanks again, Will.
Thank you. Hope to see you soon.